in a row. Anna gave a similar talk yesterday. It means that EMBO is supporting my visit to India, not just to this great meeting, but I will be visiting 2 institutes in Bangalore also Thursday and Friday. So this is really a big joy, so thank you for that. There are slides about what the EMBO organization is. You've heard it from Gerland and also from Anna yesterday. The membership, how it works, all the different grants that there are there, the publication possibilities. So I'll skip those in a second, but just to remind you that this is, I think, a very powerful organization. I got an EMBO short-term fellowship, which is now called Scientific Exchange Fellowship, for 3 months to go to the EMBL in Heidelberg as a first-year PhD student in 1991, so 35 years ago. And it really made a big impact on my career. I mean, other things also made an impact, but these small visits really changed things, even as a very early PhD student. So I think that's still very true, and it's much broader now, so really take advantage of these possibilities. I will share my journey once the slides are here, which started as a young PhD student in 1991, and then I started my first group, or my own independent group, almost 30 years ago. So I'll spend quite a bit of time on the early days of that career, although I'm, of course, you know, there's a lot I would like to share also what keeps me excited right now. I may not have too much time for it and I may rush through this in the end, but please ask me afterwards if you're interested. Yes, no. I should also say, after hearing, you know, the mentor talk so far, I'm very inspired. I was in India once before, to this exact same meeting, the YIM 2012. It was my only and first time in India, and it was very inspiring to me then, and that's also the reason why I was very happy to come again. And now hearing also Dimple talk and the other talks, it's really inspiring, and I wish we should do something like this, maybe at EMBO, also for European scientists. I know we have similar opportunities, but I think this format is really one of a kind, and you should be really proud of it. It's very inspiring. Yeah, now I do think I need my slides. Questions? Can we not do with the... This doesn't make a difference, right? Is it a problem, these colors? I mean... Yeah. I don't mind, yeah. And it's true, we tried this morning, we tried yesterday, there was no problem, yeah. Very little about, presumably, but it's really referring to the activities that are happening in my group in Delft at the moment, which is about this big collaborative project that is across the Netherlands, across Europe, and hopefully also across the globe, to have this long-term goal of building from molecular components and synthetic cell. And I would love to talk hours about that. I will just flash by some sheets at the end, but it refers to what's happening now. And I put community there, and as we've heard many times already, doing great science, in my opinion, also is collaborative, and therefore collaborative, inclusive communities that like to share things are extremely important, and I enjoy very much being involved at this time of my career of building this kind of communities. And I'll show you pictures quickly. So what about my journey? So I was actually quite privileged. I was born to 2 chemistry students when they were still studying in Utrecht in the Netherlands. And at the time, it made my mother quit her studies, and not my father, which now maybe we would frown about, at least I would. But she made it into a great career afterwards anyway. And I decided to study physics in the north of the country, theoretical physics. This is what I did my bachelor and master in, And then very early on, I had a very strong urge to go abroad. So the Netherlands is a tiny country, unlike yours, and has, of course, a long tradition of going all around the world, not always in a positive way. But I was very interested in spending some of my studies abroad. So I managed to do a diploma work, so it's my final project for my theoretical physics study in Rome, under the supervision of a professor who used to be a professor in Groningen. And I think it sort of resonates with the many things you've heard. You talk to people, you ask for help, you look for allies. And in this case, I found a professor who at the time I was interested in going abroad was also himself moving from the University of Groningen back to his university in Rome, La Sapienza. And I ended up spending almost a year there. And then after this, I actually, to go there, I also had a fellowship. But at the time, it was not so common to do this. Now, at least in the European system, you have these Erasmus fellowships. There's all kinds of ways, even for young students, to go around the world. I found a fellowship eventually, but I had to really convince the administration of the university to dig deep into their drawers to find this kind of possibilities that did exist at the time, but were not very much advertised. And then coming back to finish in 1990, I thought, okay, I want to go abroad again to do a PhD. So that was my first criterion. And then afterwards, I looked for a topic. So I interviewed with a few people, again, asked for advice from my supervisors in Groningen, and ended up going to the lab of Stanislas Leibler, who was a theoretical biophysicist who really got me into the world of biology, which I did not study at school. So I started my PhD in Paris. I was living in Paris. That's an important detail. And then did at the Serra-en-Saclay, which is just outside Paris, my PhD. I started my PhD, and then after 1 year, Stan tells me, well, actually, I got offered a job in Princeton, and I'm moving. So then I had to choose to either, having also a boyfriend still in the Netherlands, do I stay? Do I change supervisors, change topic? But I didn't. I decided to move with him. Also, I got the opportunity to move with him, and then went to Princeton, which was great. And maybe before I said this was my first introduction into biology. It was theoretical biophysics at the time. But through this stay at the EMBO, supported by EMBO that I already mentioned, which happened in the first summer of my PhD before moving to Princeton, I also got exposed to experimental biology, which I didn't pick up right away. But later, when we were in Princeton, in the theoretical physics department, Stan got a lab in the biology department, and he said, well, I have lots of money. They gave me lots of money to buy computers, to do simulations, but why don't we use it to buy microscopes, and why don't you go and buy it? So that was like, okay. But again, made a big difference. So I ended up learning a lot about equipment, talking to lots of people, and we set up an experimental biophysics lab in Princeton. And I then stayed in Princeton, in the area for my postdoc, and ended up at Bell Laboratories for a 2-year postdoc. So those were my early days, and then I was in a French network because of my supervisor and some other people that were in the lab, and somehow through this, which is, I guess it happens in many countries, knowing the people, knowing the network, I got into this possibility of applying for a permanent position at the CNRS, which is the French National Research System, to go to a lab in Strasbourg, and they even offered me the position permanent, but without too much independence and funding, which was important to me. And we had already drunken champagne in Strasbourg. And then I got an offer from an institute in Amsterdam for a non-permanent tenure-track position, and I decided to choose that. It was a new environment. Of course, it was home for me. I also applied in the US, by the way, at Cornell, which I did not get, which I did also not regret in the end. So, all this seemed like a plan, but it was really driven by my initial desire to go abroad. So the hidden agenda was always to live in these big cities. So I was in Rome, and then in Paris, and then in New York, but only to end up in Amsterdam. And that's where I've been the last, not in the city, but in the Netherlands. So what happened after that? Like I said, to me important were the fact that it was experimental biophysics that was grown through these visits to the EMBO, to the possibility to build a lab in Princeton. None of it anticipated. But then that was important to me. It was not a topic very much on the on the research agenda in the Netherlands yet. I mean, there was quite a bit of biophysics, but not at the molecular scale, the nanoscale that I wanted to do this. And also the Netherlands still, to some extent, but certainly at the time, was quite a hierarchical system. And I really wanted an independent position. That's why I chose this tenure track instead of a permanent position. And I also chose this institute, AMOLF, where no biophysics really was happening yet at the time, but they were very interested in building it. And they had, since many years already, this independent system with responsibility, but also freedom to build your own research line. So that was extremely important to me. Also as a female, I mean, still in everywhere, but also in the Dutch system, I was one of the very few students, female students in theoretical physics, and especially in hierarchical places at the universities, it was and sometimes still is a problem for women in STEM. So another reason for me, I didn't think about it that way at the time, but intuitively is probably why independence was so important to me early on. So I was at AMOL for a long time, 17 years. I was listening to Mohan, and sort of the time scales resonated a bit with me after 15, 17 years. Actually, already a bit earlier, I became department chair. I was part of the management team. But it's like, okay, I've seen this building now for so many years. I walk into the same building every year. Fortunately, I get students that, new faces all the time. Things change, the experiments change, but still, I actually applied to be the director of AMOLF, but they hired somebody else. Fine, but that was another good trigger to say, okay, maybe now I should go somewhere else. Before that, the institute was always saying, well, we're just building this biophysics, and why don't you stay a bit longer, because we're not done yet. But I ended up being recruited in 2014 by the TU Delft, which is where I am now, as a professor of bio-nanoscience. So that's why I've been since 2014. Again, I was recruited to be a professor in biophysics, but also to be the department chair at the same time, because it was a very young department with lots of new people coming. It was a young department with lots of people who had only started their groups fairly recently. So they were looking for an external person to also be the chair, and I enjoyed that very much. In between, I was teaching at Leiden University, so I've had an affiliation there for a long time. I still have, but it's just a teaching affiliation, or it was initially, and now it's a part of a larger Delft-Leiden collaboration scheme. And I also, after the initial years where setting up the group, and I will talk a bit about the science and the funding, everything running smoothly, I went after 10 years to do a sabbatical year in Rotterdam. And this was at the same time that I had my first child. So I had babies in 2007 and 2009. I was again interested in going abroad for a sabbatical. I was looking even at China, maybe. Grants were coming up there for foreigners to come and spend some time. But then I got pregnant and said, okay, well, maybe not China, and I will still go to a sabbatical. I ended up in Anna Akmanova's lab. So if you're in my field, microtubule field, then you know who Anna Akmanova is. And so we were born in the same year. We have the very similar interest and passion in the microtubule cytoskeleton, but a very different approach to studying it. So it was sort of a perfect match. And I learned to do some cell biology in her lab. And that was also sort of in a period where everything in the lab was already moving quite smoothly, so I could afford to do the things. Also to have babies. I had my children quite late. I'm 58 now, so if you count back, I had my first child when I was almost 40, and never a conscious choice, but sort of the way the things went. We were talking about age being an issue for having an independent group, but it's also an issue, of course, for having babies. And I was lucky. I consider myself lucky to have now still 2 healthy children. So then the last thing on this list is I'm currently, since 2022, also the president of our National Academy of Sciences. So that's something that is a huge honor to do. It takes about 60% of my time right now. So it also shows that the last 10 years or so of my career, I've been doing this, half running the lab, half being either department chair or now at the Academy, which will finish in June this year, so I'll be free again to do other things. So, and again, I will not spend too much time on this, but if you're interested, this is very important to me. So this is a picture during the pandemic. I was department chair during the pandemic, and this is when my goodbye, let's say, as a department chair, which was online in 2021, people thanking me. And this is a few years ago when I was installing new members of the Academy. I will leave that to the questions. So now about the science. So this has been my obsession forever, is the microtubule cytoskeleton. This is this movie, I forgot to put the reference, but it's the Inner Life of the Cell movie that was made in Harvard many years ago. And this is the artist impression of the microtubule filament that has this very peculiar dynamic properties where it can grow and switch from a growing to a shrinking state and quickly disassemble. And these dynamic properties are extremely important for many cellular processes, building the mitotic spindle, cell motility, neuronal cells, and the dynamic properties are very tailored to the specific function that this polymer has in different cellular contexts. And important to my research, it's also a force-generating machine. So because these filaments are very stiff, they grow and they can push, for example, on chromosomes during cell division. And when they shrink, provided that you have something to hook up to these filaments, they can also pull. And from now I'm going to go quite quickly through the pictures just to give you a flavor of the kind of approaches we take. And I'll be happy to talk about it more later. So I always say that this slide is the story of my scientific life, because we've been always working on going from studying the dynamic properties of individual filaments to the force-generating properties of these filaments, building in what I call functional complexity towards building multi-filament systems in confined spaces to study really how the forces and dynamic properties of individual filaments, also under the control of other molecular components, contribute to the spatial organization of cells. And and the pictures on the top are in vivo pictures, usually taken by collaborators, although we did a little bit of in vivo work ourselves on fission yeast. And the bottom row are the in vitro experiments, the reconstitution experiments, to isolate the specific properties that we want to study in controlled minimal systems. And so that we can, I don't think this picture is very clear because of the color, but we can then in vesicles, or in this case in microfluidic droplets, rebuild what we call minimal mitotic spindles, where we know exactly what we put in, and we can combine with theoretical models to understand the force balances that lead to this kind of organization. Okay, apart from the sort of going to the functional complexity, more component cellular scale, more recently we've also went to the smaller scale, and again I'm just flashing it by using electron microscopy techniques, which is relatively new to our group, to also zoom in to the molecular components, how they organize themselves specifically at the ends of dynamic microtubules. And this is an ongoing collaboration with Anna Akmanova that I've been collaborating with ever since. So a little bit about the funding. So throughout my career, I took advantage of the different possibilities that are there. I already mentioned the fellowships, like the EMBO and the Italian government. And then as an independent group leader, I first relied in the first few years on project grants. So I came to a very comfortable situation in the AMOF Institute, but without PhD students. So we have 0 PhD students in our system. They all have to be externally funded. And with money for 1 microscope, although I had to negotiate a little bit, I asked for, at the time, $100,000 for a microscope, which is 200,000 guilders at the time before the euro. And then the financial officer at the institute thought that I had asked for 100,000 guilders. I said, no, $100,000. So I need twice the amount, otherwise I cannot buy a microscope. So little things like this. But that's first. So the first PhD student that I graduated on the basis of such a grant was 5 years later. So that took quite a while initially to get the first projects out, even a bit longer than the 10-year clock, which was 4 years, 5 years at AMOF. So you somehow, this is the vulnerable moment where you have to argue, there's still more coming, but you know, this is we already achieved, it's not all yet published, so that's a sensitive moment, but I came through it. And from then on, I had actually a few personal grants, and the ESC Synergy, if you know the European system, it is a collaborative grant. It's with 2 PIs, and I got it with Anna Akmanova. So being in her lab in 2007 really made this large joint grant possible. And from then on, in the last 20 plus years, I've only written collaborative grants, so I cannot confirm more what everybody has said already. It's really a pleasure to be in these collaborative projects, and you learn so much more, and you can do so much more, and you somehow have to, of course, to your administration explain what your contribution is, but never avoid it for that reason. I really think I agree with what was said already before. So about collaborative grants, and this is what I already warned you for, I will go quick. So currently, in the last 10 years or so, we've been building consortia, first in the Netherlands, to say, okay, if we can build a small cytoskeleton, if we can build a small ATP regenerating system, or even a synthesis system, if we can do DNA replication in vitro, if you can do gene expression in vitro, which you can now with cell-free systems, if you can do mechanical constriction, like Mohan talked about, can we find a way, not tomorrow in 5 years, but eventually to learn how to put this all together, to build a minimal version, not a real cell, not a bacteria, but something that mimics a cell, that can do autonomous growth and division as a way to learn more about how real cells work. So it's really an engineering approach to learning more about biology, but also eventually if you can make this kind of cell factories, it would provide for all kind of applications, a new kind of biotechnology, which is what we keep explaining. The administration in Brussels, we think we should not do this only on a national level, we should do it on a European level, really collaborate towards this long-term goal, and then with the possibility of having really new kinds of applications possible. So we have quite a good funding in the Netherlands. We had some initial results. We actually got recently another consortium granted, and these are 10-year programs, and this is great. I mean, it's very exceptional, but if you have a 10-year program to collaborate with many people, so I'm very thankful that at least funding in the Netherlands in the last 2 years, because of government changes, had not been great, but at least we have these 10-year programs, which are very powerful. And it meant for my group that we had to switch. Of course, we don't let go of the microtubule cytoskeleton, but for a minimal cell, we need a DNA segregation system. That's what we're working on based on prokaryotic filaments, because that can be expressed in a cell-free system. Okay. This was one of the slides provided to us to what we could talk about, building a research group. I will not say too much about it. You can ask me. I recognize many of the things that were said already before in other mentor talks, but I do want to show the picture of my group because it's essential that they work as a team, that they are, as was mentioned also by other people, that they are collaborative and inclusive and help each other, especially with me doing also other things on the time. I'm there on Wednesday and Friday, so I talk to everybody every week, but I'm not there the rest of the week, so they really have to collaborate together. This is when we were walking on the bottom of the sea, which is what you can do in the Netherlands, and other random pictures from the last years. So maybe just this, as I said, there's challenges for building a group and how to supervise, but there's also challenges for group members, and one of them is, especially at this time of my career when I'm not always there, but also these experiments, they take time and they often fail. So sometimes or often an experiment only starts to work in the 4th year of the PhD or even later, and somehow you have to stomach that as a PhD student. And there's important to have a lot of communication on what does that mean for publication expectations and things like this. So I'll just as promised show you some pictures of building these collaborative networks in Europe. So we have what we call a SynCell EU office. There's a website here that you can look. If you want to be part of that community, you can simply sign up for our website. So this is mostly European, but as you can see from this map, this is already a few years old, maybe 2 years old. Scientists from all over the world signing up to this website, and you're very welcome to join. We just had a meeting with networks, a smaller meeting from Europe, the US, and Asia on this topic last year, and we'll have another one in April. applications I already talked about. This is, of course, all in the future, although some of our community members are already working on applications based on this technology. And then maybe the last slide before I give you the takeaways is what is important to me also at this time of the career, and that is, to take responsibility for the system, being at the academy as part of that, and responsibility for the field, which is this building this cell community. And recently, and this is something I also care very much about, I've become a member of the Bioethics Committee of UNESCO. It's a way for me to learn completely new things. There's ethicists, philosophers, human rights advocates from all over the world in this panel to talk about the impact of technology and biology for the world and how it should be developed in a way that benefits us all. So this, I'm just going to show the picture. And that's maybe one of the messages also is that no matter where you are, it's important to continue to learn new things and be challenged by people that know things you do not know. And this is what I get from being a part of this committee. So that's it. I'll stop. I think, there are many takeaways, and you will recognize many of these from other mentor talks. I think the most important one is have fun. It was already mentioned, if you do not enjoy what you're doing, it's going to be a very long road, so you really have to follow your passion, collaborate, we've seen it, organize, help, and negotiate. We've heard about that as well. Don't ever do anything alone. Negotiate, and at home as well. I'll flash by the picture of my family very quickly because they don't like it when I do this. And, don't always believe or follow the rules. I mean, we've heard about what about this rule? People tell me I should do this. What is the reason that people tell you to do this, and find out about that, and don't simply follow those rules, and maybe find another way around it if it suits you. Avoid hierarchy, for me, was very important. As a female in the Netherlands, in the Dutch system, adapt, recognize opportunities, it's nothing new. And, make sure you have a plan B or even A towards happiness is I think what somebody said, Anna said, I think. It's not the end of the world if things don't work, you don't get tenure. You should enjoy life somehow anyway, and not let that depend on your work, and continue to learn. So, thank you very much.
Thank you, Marileen, for sharing your journey. Questions?
Thank you so much for sharing your journey with us, and very inspiring. So I have started working on a project to make something similar, but on a smaller scale, synthetic mitochondria.
Yeah.
So it was very relieving to know that I was not crazy to start something and get a validation from somebody like of your stature.
Well, I can tell you about the reviewer reports we got the first time we made suggestions like this. But go on. Yeah.
Yes. So my question is that. Are you also collaborating with BioHub and others in US like Chance Network?
Yeah, so we are in very close contact with the Build a Cell community. So this is Kate Adamala and others. So they don't have a funded program in the US, but they have funding for organizing themselves on this topic. So that's the main network we are collaborating or interacting with, sometimes also collaborating with. And I don't know if they have a relation to the network that you are mentioning. And actually, we have a yearly meeting on synthetic cells that so far has alternated between the US and Europe. But I think we should organize one of the next ones in Asia somewhere to make this truly global. And I hope that answers your question.
Thank you very much. And I would definitely want, if there's a possibility to part of this network.
Just sign up. You can go to the website and you will be. You can sign up. Yeah.
Thank you.
Yeah.
Thank you, ma'am. I have just one basic question. How did you move from physics to cell biology? Because in order to escape from physics, chemistry, or maths, we will take biotechnology. But we will get punished by biophysics, biochemistry, and biostatistics. So, and we hated it. So,
which part did you hate? Sorry.
How did you reach from physics to cell biology? I wonder what driven you to change the core subject itself.
So I think it's a series of sort of events. that, and in the end, it's about that you get sort of at some point really grabbed by the topic, right? So I liked, in high school, I liked mathematics mostly. So, and then I thought, oh, but if I study mathematics, it's only theoretical, so let's look for something where I can apply mathematics, so it became physics. But I still liked the theoretical part very much. And then being a PhD student, and my supervisor sent me to the EMBL, which is with the EMBO fellowship, and there I got to see biology, I got to see a dividing cell and the microscope, and you sort of get, okay, you know, physics is easy. It's all predictable, you can write formulas, but biology is not, it's not easy, it's very complex, and you can do some formulas and modeling and more now, also now that we know much more, but it's in a way much more challenging. So it's somehow I got interested, even though I did not like biology in high school. Yeah.
Thank you.
Any other question for Marileen? Yeah.
Thank you very much for your nice talk, Marileen. And I think it's a very nice example of how you can be how as an excellent scientist you're also contributing to the science, the society of science, the scientific community, and how things are being run. Now my question to you is, so earlier this week, Rajesh Gokhale, the secretary of DBT, said that he believed what we are entering now is the age of biology, rather than the age of AI. And from what you're saying, your ambitions with the artificial cell and whatever you can do with that in the end, you also seem to believe that.
Yeah, I think, I mean, one of oh, you don't see it anymore. So this one of the slides with the applications that I flashed by too quickly says, you know, nature is our new technology, and nature knows how to build crazy things, and if we can harness in a sustainable way, that's still, of course, also an important part of it, and I think that was stressed also before, that it can be in a much more oh, okay. Yeah, so I completely agree. I think that the emphasis that he had was more on using existing biology, of course, for all kinds of new technologies, for energy. But this would be a complementary route to add to that, I think. And as I said, I mean, we applied for a collaborative grant on building a synthetic cell the first time in 2013 already. And then we got reviewers back and they said, you are crazy. I mean, it's completely impossible, and what are you thinking? So we got really trashed. Then for a few years later, with some extra developments, we tried again, and we ended up at the top of the list. So sometimes it's too early, but that doesn't mean you cannot still work on it secretly in your lab and then apply again for funding later. And that still doesn't mean that we will be able to build, you know, it's quite something to build an autonomously growing, dividing cell-like system, which can be much simpler than a real cell. It's fine. And we also always said that even if it never works, going through the process of trying, you learn a lot about real biology, and there will be intermediate steps where biotechnology will benefit. I mean, to some extent, people call the mRNA vaccine already in this area because you use some lipids and a piece of RNA that is also inspired by the way biology does it, of course, in a doable complexity, let's say. I mean, it's amazing that it works, but still. So how far we will get, we will see. And there's alternative approaches. We use, you know, what we call inspired by existing biology, so DNA replication, normal transcription based on DNA, RNA, protein. But you can also think about hybrid systems or use DNA origami or supramolecular chemistry. There's other ways that you can mimic lifelike properties, and other groups in this bigger network are taking different approaches and somehow combining that to mimic the properties, not to rebuild the cell as we already have it, because we don't need to do that. We have real cells already. Yeah.
Any other question?
Yeah. Marileen, this is very, it's really insightful. So it's not a question, it's a curiosity that morning Dimple also has explained that age is the issue, family is another responsibility, traveling from one country to another country, then at the same time changing the topics. After having all these troubles, I can say problems or things, how you keep yourself motivated?
Yeah, I think I would give the same answer.
No, but I know that we like this. Yeah, we like this, but still.
Yeah, so I think, I mean, so there's a few things that I really, really like, and that from early on is the science itself, just to be able to solve puzzles, to do experiments. I didn't think I would enjoy doing experiments so much, but I do. It's something I have, by accident learned because of the journey that I took. So, and I also enjoy tremendously working with young people from all over the world. So get all these different perspectives, see all this talent, this motivation, and that's a big. I'm now in a university since in Delft. Before I was a research institute, which is also quite young, but the university is even better in a way because there's young students everywhere. So that is very motivating. Being able to, to continue to learn, to contribute in different ways to the system. And then, and then the last thing is that, and that's really, I always told myself, I will be happy anyway, whatever happens. So if I have to do something completely different, I'll find another way to enjoy my life. Of course, being, in a fairly privileged situation, as I've always been in the Netherlands. It's safe. It's fairly rich, and there's challenges, but also tremendous opportunities. So somehow you take those, and I could imagine, not yet. So far, I've not been willing to give up the research. So now I'm 40% in the lab, 60% at the academy. I could, be and I've been asked to be, at the leadership of the university, which would be 100% of my time administration. Maybe I will do that one day, but I'm not ready yet. And the clock is ticking, so 10 more years, so it may never happen. And that being in the lab, working with young people, looking at data, is still the core. So I don't want to give that up, and that's the big motivation. Yeah.
Let's thank Marileen once again.